copy over example 4 into example 5 into example 6. I'm going to open it up in Spider. All right, so I'm going to call this example 6. Still going to use the modified NIST data set. And we're going to have multi-class stochastic gradient descent classifier. Still going to load my data set. Still going to have my X trains. And I think that's as far as I'm going to go. Everything from after that, we're just going to read. I'm going to get rid of that too. We're just going to rework everything after this. So let's go to a new section, train the multi-class stochastic gradient descent. So we'll have to do sum in 1 verse 1, sum in 1 verse rest. Okay, one thing I am interested in is going to be timing this, because I am interested in kind of what operates faster. Let's go tt_1 is equal to time.time. And for that, I'm going to have to import time as time. And I'm going to go OVR_CLF is equal to sk.multiclass.capital 1, capital V for verse, capital rest classifier. And now I need a model. So we're just going to train it in this. We're going to go sk.linear_model stochastic gradient descent classifier. First 4 letters are capital. Open and close it out. That should give me a one verse rest classifier. Now I need to train that model. So 1 verse rest underscore CLF dot fit. We're no longer building 5 detectors. Woot. So we can go x underscore train comma y underscore train. And then let's go print string 1 verse rest took space plus str. We'll go time dot time open and close parentheses. That gets me my time now minus tt_1, because time only moves forward. We'll go plus string space seconds to train and execute. Well, to train, we don't really predict. Hit F5 and we'll see if we get any errors. So far, no errors. sklearn has no attribute multi-class. Okay, that makes sense. So from sklearn import all one word, multiclass. M-U-L-T-I. Now let's see how that works out. Still waiting for a response. All right, I'm going to assume that that is training, right? So we can also build this was a one verse rest. We can do the same thing for a one verse one. So I'm just going to copy it on down, and it's one verse one. And that is going to be TT of 1 minus time, multi-class, one verse one classifier. I think everything else stays the same. I should probably rename it. OVO, classifier fit X train Y train, one verse one. Took so many seconds to train. I'm still training my one verse rest. I mean, I don't see why it would have to be labeled, but with on-label data, you're typically doing clustering. But the ideas of one verse one and one verse rest are not specific to labeled data. The particular classifiers that we have here might be. Does that make sense? So we just sit and wait. Did anyone get theirs to run? Your computer might be faster than me. Anyone's finished? How many seconds? Okay, 174 seconds for one verse rest. All right, so now I don't want to run that entire thing again. I'm just going to highlight this one and hit F9. Let's see if we can beat it. So yeah.
Line for one versus rest give me 108. So should be like again. Like mine gave me 108 seconds. And like down here is 174. So like
You have a faster computer than me.
this one is a point.
I mean, yeah, if you have a faster computer, you'll train faster, right? Sometimes a lot of people with like really fast computers and they'll do it in like 40 seconds, and I feel quite sad. But yeah, my computer is up here. Like, you could cook an egg on this thing right now. Like, it is just. Although astonishingly, the fan's still not on. I don't think the fan works on this. Okay. One verse one took 46 seconds. I train 45 models instead of 10 models, but I don't have to process as much data, right? Not that this is actually problematic, but 174 seconds, 46 seconds. If this were to scale, and maybe instead of seconds, those were minutes or hours, right? 2 days versus several days, could mean the difference between kind of a profitable company and an unprofitable company. So something good to think about. So of course, sklearn says, here, let's do one last one, right? So we don't always have to classify this, right? A lot of times we just know what generally works better for a specific algorithm and generally scales better. So sklearn detects when you try to use a binary classifier algorithm. Whoop. Classification algorithm for a multi-class problem and automatically runs OVA. Except sometimes for like a support vector machine, it might run OVO, but that's fine, right? So it has something predetermined. So if we were to try to do that, it'd be TT minus 1 is equal to time dot time. And then instead of telling it which type of classifier we have, let's just give it a classifier. We're going to just say multi stochastic gradient descent COF is equal to sk.linear underscore model dot stochastic gradient descent classifier. Multi stochastic gradient descent COF dot fit x underscore train comma y underscore train. And then I can go ahead and print that one and say sklearn's automated OVA. So let's say sklearn's automated one verse. They call it one verse all, but it could also be one verse rest, right? Took so many seconds, and if I hit that F9, whoop,
You have a hyphen instead of an equal sign.
Thank you. If I run that, we can see how long it takes. It'll take the same exact same as what it took before. And I'll just wait to see the number for a sanity check. But any questions? That gets us to the end of class. We'll have class tomorrow. Yes.
So did that just classify every image in the data set?
Yes. It classified ones as ones, twos as twos. You can give it an image and it'll give you a prediction. But we will play around with that on the next example. Right now, we're just training and looking at speeds of training. Just sit here and wait. All right, took 154 seconds for the one verse all or one verse rest kind of automatically selected. So just because it selects it doesn't mean it's the fastest, but maybe it scales better, or it just isn't a big enough deal. So something to think about.